Good morning, everybody. Hope you guys are having a good Friday. Our topic today is what I like to call table derivatives. It doesn't really have a name, but they all kind of take on this form where you have tables and you have to find f prime of something or h prime of something. And so it's not too long of a lesson. I'm going to go through a couple of examples, but I want to start off just by talking to you about what your homework is going to be. So let's do that. Let's go through and circle these problems that you're going to need to do. So you need to do all of problem number 1, all of problem number 2, and then if you'll turn the page. Okay, so let's get turned back to problem number 1, and let's take a look at how to do this. I think maybe I'll do questions 1C so you can see how the whole thing works. And these all basically follow this same method, and that is that we're given some function. So in this case, I need to find k prime of 2. So k of x is equal to f of x over g of x. Hopefully when you look at this, you can see that this is going to be a quotient rule derivative, right? So I've got to first take this thing and find k prime of x. So let's do that. Now, we know that quotient rule is fig minus gif over g squared, right? And so in this case, and this is just kind of a lucky case, my top function is f, just like in my formula, and my bottom function is g, just like my formula. And so my actual derivative here, and it won't always work out quite this way, but it does here, that k of x is equal to f prime of x times g of x minus g prime of x times f of x all over g of x quantity squared, right? And now I need to find k prime of 2. And so k prime of 2 would look like this. Oops, that should have a prime on it right there, sorry. K prime of 2 will look like this. K prime of 2 would be equal to f prime of 2 times g of 2 minus g prime of 2 times f of 2 all over g of 2 quantity squared. All right, all I did there was I just took all of the x's, right, and replace them with 2's. And so now I'm going to use my table. And when I do this, I get that k prime of 2 is equal to, so f prime of 2, I go up to this table, here's the f prime row, here's the 2 column, so f prime of 2 is negative 1. G of 2, so I go up here to the G row, and the 2 column, G of 2 is negative 5. Minus G prime of 2, G prime of 2 is 0 times f of 2. F of 2 is 2 over, and g of 2 quantity squared, so g of 2 is negative 5. So negative 5 squared. Now all I've got to do is simplify this expression. So negative 1 times negative 5 is 5. 0 times 2 is 0. So that numerator becomes a 5 over. And then negative 5 squared is obviously positive 25. And that is equal to 1/5. And that's my answer. Right, so the whole key to this is understanding that you've got to take the derivative. And again, in this case, it was f over g, but oftentimes they'll change this notation. They may say it's, I don't know, f over h or something like that. So you've just got to write out your derivative, plug in the value, and then get everything that you need from the tables that you're given. And the one thing that I see place that people tend to make mistakes is just not being careful, making sure you go to the right row and the right column to get the right answer. All right? So that's question number 1. Let's take a look now at question number 2. And I'm going to do question 2bi. Okay? And so in this case, I'm given this function k of x, which is g of f of x. And I don't know if you recall me saying this, but I always say that I hate notation that looks like that. I always rewrite it as g of f of x. To me, it just looks more like notation that we typically use. And so again, I'm being asked to find k prime of 0, so I've got to take the derivative of this expression. This is a chain rule derivative, right? So let's take that derivative. K prime of x will be equal to, so my outside function is g, my inside function is f. This is different from how it normally is, right? So I'm going to take the derivative of the outside. The derivative of g is, of course, g prime. Everything on the inside stays the same, times, and now I go inside my parentheses and take the derivative of this thing, and the derivative of f is simply f prime of x. Okay? So now I'm being asked to find k prime of 0. K prime of 0, so that's just like in the last one, we just plug in zeros. This is going to be g prime of f of 0 times f prime of 0. So this is where people tend to get a little screwed up. So we just need to be careful here. The f prime of 0, that part is pretty straightforward, right? So if we look at our table here, f prime of 0, so here's f, g, f prime, here's f prime, here's 0, so f prime of 0 is 5. But now this other expression, g prime of f of 0, this is going to take me 2 steps. First thing I've got to do is find f of 0. So I go to the f column, 0 row, f of 0 is 1. And so this thing I can rewrite as g prime of 1, since we know that f of 0 is equal to 1. All right, so I've still got to figure out what g prime of 1 is. So I go up here, here's g prime, here's 1, it's -5/3. And so I now rewrite one more step. G prime of 1 becomes -5/3 times 5, and so -25/3. And that's my answer. So that's how you do number 2 when you have chain rule, right? It's a little bit more complicated. It's a little bit more confusing. But you've just got to get your formula correct in the beginning, and then, again, be careful when you're going through your table and pulling out values. I think it's helpful to rewrite this. So in my case, g of f of x, up for part A, you'll do f of g of x. So you still need to do k prime of 1, h prime of 0, and h prime of 1. So go ahead and get started on those. And that's basically all we've got to cover for today. Oh, well, no, that's not right. We really should look at problem 109. To 109 and 110, we're going to do both of those. And I know these are out of order. Turn the page again. Okay, taking a look at problem 109. Now, I'm not going to actually do 109, but I do want to talk to you about how to handle it. So what's going to happen is you're going to be looking for certain values. For example, maybe you're going to need to know f of 2 and f prime of 2, right? Or g prime of 1. And what is it you do? Well, recall what f of 2 tells us is just the y value when x is equal to 2. And so all I've got to do is go to x equal 2, go up to my f function, and it's right there, right? So it would be that y value, and so f of 2 is simply equal to 7. F prime of 2 is also a tractable question. F prime of 2, what's the derivative tell us about a function? It tells us the slope. And so now I just need to look at this line and find the slope of this line. I can tell pretty quickly this line has a slope of positive 1. And so f prime of 2 is equal to 1. So when you do these problems, you're not going to be using 2, you're going to be using 1 and 5. But it's the same issue when you're trying to evaluate your derivative. You've got to do the chain rule derivative. But when you try to evaluate and you're trying to plug in values, the key is you're either looking for y values or you're looking for the slope of the line that you're working on. So just be careful, make sure you calculate your slopes accurately. That's really all you need to know to do this lesson. So go ahead and get started on that homework. I think you can have it done before you walk out of the classroom. Compare answers with each other once you're finished. Do it on your own first, right? Do it on your own first, then compare answers. Make sure you guys are all getting the same answers. All right, enjoy your weekend. Thanks a lot. I'll talk to you Monday. Oh, by the way, I'll post the answers. I've already posted the answers to yesterday's homework on Edsby. And problem 108. Okay? So that is all of your homework. That was 1 and 2 on page 1. 109 and 110 on page 2, and 108 on page 3. While we're not really ready to do all these problems yet, be sure and hang on to this thing for the future because there are some really great challenging problems in here that we can do at another time.